Okay, we're going to talk about how to use SOHCAHTOA for trig. So SOHCAHTOA. That is the acronym that helps us remember that the sine of an angle, sine theta, equals the opposite over the hypotenuse, O over H. The cosine theta is the adjacent over hypotenuse. And tan theta equals opposite over adjacent. All right, so we'll talk about what these things mean. Okay, so theta is our variable for angle. Okay, so this is our theta. Okay, so if we're talking about theta, first of all, we can only use trig when we have a right triangle. So for a right triangle, across from the 90-degree angle, or opposite of the 90-degree angle, is always the hypotenuse. That's our longest side. And then we have two legs. We have the leg that's opposite of theta. So in other words, it's across the street from theta. Opposite side of the street, not touching. Okay. Then the adjacent leg that is touching theta. So the hypotenuse is touching theta, but the adjacent leg is also touching theta. So it's the other side that makes up that angle theta. The opposite side doesn't even make up the angle at all. Okay. So there are three trig functions. We've got sine, cosine, and tangent. So this is pronounced sine because it's short for S-I-N-E. S-I-N, short for S-I-N-E. Cos, C-O-S, is short for cosine. And then T-A-N is short for tangent. So those are our three trig functions: sine, cosine, and tangent. Now, the ratios are the sine of theta is equal to the opposite over the hypotenuse. So that gives us this first little part of the acronym, SOH. The cosine is adjacent over hypotenuse. That gives us the second part of that acronym. And then the tangent is opposite over adjacent. That gives us the third part of that acronym. Okay, so we're going to look at how that's going to help us with the unit circle. So this is all about the unit circle. All right, so we've got two special right triangles that we use for the unit circle. The first one that I'm going to talk about is a 30-60-90. So it's called a 30-60-90. You learned about this in geometry because it's a right triangle, so that's our 90, and the angles are 30 and 60. This is half of an equilateral triangle. So the hypotenuse is 2. The short leg, the one across from 30, is 1. And the long leg, the one across from 60, is the square root of 3. Okay, so we're going to look at this one to see what the sine, the cosine, and tangent of 30 is, and what the sine, the cosine, and tangent of 60 is. So we'll start with 60. So we're going to do sine 60. Okay, so let's see, we'll go ahead and say cosine 60 and tangent 60. All right, so if we're looking at 60 as our theta, the square root of 3 is the opposite leg. So this is the opposite leg. 1 is the adjacent leg, and 2 is the hypotenuse. Okay, so we just have to use those numbers to fill this out. So the sine of 60, SOH, is the square root of 3 over 2. Opposite over hypotenuse. The cosine of 60 is the adjacent over hypotenuse, so it's 1 over 2. The tangent of 60 is opposite over adjacent, so it's the square root of 3 over 1. So you can just simplify that to be square root of 3. Right now we're going to do 30. So I'm going to get rid of opposite and adjacent. Hypotenuse is always hypotenuse, no matter what. No matter what angle we're talking about, hypotenuse is hypotenuse. Now, whichever angle we're looking at determines what opposite and adjacent is. So for 30 degrees, square root of 3 is adjacent. It's touching 30 degrees. 1 is the opposite. So we're doing sine of 30 opposite over hypotenuse is 1 over 2. Sine of 60 adjacent, I'm sorry, not sine. I did that backward, wrong. Cosine 60. I already did sine. Cosine 60 is adjacent over hypotenuse, so square root of 3 over 2. And then tangent, oh boy, I am really messing up here, sorry. We're talking 30, not 60. Okay, and then tangent of 30 is opposite over adjacent. So it's 1 over the square root of 3. Now, if we notice, look back up here, the sine of 60 is square root of 3 over 2. The cosine of 30 is the square root of 3 over 2. The cosine of 60 is 1/2, while the sine of 30 is 1/2. So since 60 and 30 are complementary, they add up to 90, then the sine of 60 equals the cosine of 30. So the sine is also always going to equal the cosine of the complementary angle. And then if we look at tangent, it's just upside down. So tangent of 60 square root of 3 over 1. Tangent of 30 is 1 over square root of 3. Now we don't ever have a square root in our denominator, so we're going to rationalize that denominator. So I'll come over here and we're going to go 1 over the square root of 3. We're going to rationalize the denominator by multiplying it by a form of 1. That is the square root of 3 over the square root of 3. So 1 times the square root of 3 on top. And then square root of 3 times the square root of 3 rationalizes that bottom number. So 1 over the square root of 3 is equal, it's the same thing, it's rationalized to be square root of 3 over 3. That's the one that we're going to use when we're doing tangent. Okay, so now we're going to look at the other special right triangle that we use in the unit circle, and that's a 45, 45, 90. So, so now in this case, you know, you only have one angle to worry about. So we just have 45-degree angle. So we're doing the sine 45, cosine 45, and tan 45. All right, so we can use either angle, they're equal. So we'll just say that's opposite and that's adjacent. It doesn't matter. This one's going to be our hypotenuse. All right, so opposite over hypotenuse, 1 over square root of 2. Cosine is adjacent over hypotenuse, same exact thing. Cosine and sine are equal, since 45 and 45 are equal. And then tangent is opposite over adjacent, so it's equal to 1. 1 over 1. Okay, now again, we can't have a square root in the denominator, so we're going to have to rationalize the denominator. So we're going to go 1 over square root of 2, and we're going to multiply. This time, we're going to multiply by a form of 1 using square root of 2. So square root of 2 over square root of 2. And so we get square root of 2 on top, and square root of 2 times square root of 2 on bottom gives us 2. So we're going to rewrite the sine of 45 as the square root of 2 over 2. And we're going to rewrite the cosine of 45 as the square root of 2 over 2. Okay, so make sure you're pausing and taking notes. Okay, so if we're going to use this to fill in the unit circle, so this is how this works for the unit circle. Okay, so that your unit circle, that blank that you were given, has these angles laid out. So like this is 30 degrees. So let's first look at that. I might have, hang on, let me see if I pulled up a picture that has this. Yeah. So if we look at this right here, we can see this 30, 60, 90 triangle in in our unit circle. So if you can notice here that, let's see, that these little lines, let me just explain how these lines work. Okay, so these lines, these dashed lines, this first one is showing 30 degrees. So you see 30 degrees, okay? The second one is 15 degrees further, so it's 45 degrees. And then this third line is 15 degrees past that, so it's 60 degrees. So if you look at this first triangle here, the unit circle means that our hypotenuse is 1. Okay, so in a 30, 60, 90 triangle, the short leg is half of the hypotenuse. So if we're looking at how far up that is and how far up that is, that's why that's 1/2. Okay, and then this one is the square root of 3 over 2. So it's the short leg times the square root of 3. So the long leg is always going to be the short leg times the square root of 3. When we did that, hang on, let's go back and take a look at that. So when we were looking at 30, 60, 90 triangle, we were using 2, right? We were using 2 as our hypotenuse, okay? And then, but instead we're using 1 as our hypotenuse in the unit circle. I don't know why I thought it was important to tell you that, but I did. So we're using 1 in the unit circle. So anyway, this distance here is, this gives us our cosine is x. So write down that the cosine equals x and the sine equals y. So whatever the cosine is, that gives us x, and whatever the sine is, that gives us y. So that's something to keep in mind. So let's go back to the unit circle, and let's look at the 30, 45, 60. Let's do that part first. Okay, so if we're filling in this unit circle, we look, and we've got 30 degrees right there, 45 degrees right there, and 60 degrees right there. Okay, and straight up is 90 degrees. Okay, now if you notice, we've got we're going 30 more degrees this way. So because from 60 to 90, that's 30. So from 90, we're going to add 30 more. Actually, what I like to do is count by 30s. So I'm going to get rid of the 45. So let's do that. Let's go first. We're going to count by 30s. So that's, this first one's 30, 60, 90. So we're just going to count by 30s. 30, 60, 90. And then right here, we've got 120. And then 30 more right there. We've got 150. 30 more, that's 180. 30 more is 210. 30 more is 240. 30 more is 270. 30 more, 300. 30 more is 330. And then 30 more is 360. And that got us back to 0. So right up there, we're going to say that from on the top part, we're going to call that angle 0 degrees. And then if we make a full circle, a 360-degree turn, we get all the way back around. So, excuse me, we're gonna just do that to start with. Okay, now if we want, we can go ahead and put our 45 degrees, all the ones that are going to relate to 45 in there. So if we add 15 to 30, that's going to give us 45 right there. Okay, let's go over here and add 15 to 120, and we get 135. Okay, we go down here into the third quadrant. We add 15 to 210. That gives us 225. Okay, and then over here in the fourth quadrant, if we add 15 to 300, that gives us 315. Okay, so that's all in degrees. Let's look at what it looks like in radians. So pi equals 180 degrees. So pi radians equals 180 degrees. So over here, I'm going to put pi. Actually, let me get a different color. So let's go with purple. So I've got pi is 180 degrees. All right, well, 90 is half of 180. So it stands to reason that 90 would be pi over 2. Pi divided by 2. Okay. And then if you notice this 45 right there, that's a fourth. So that's halfway up to 90. 45 is half of 90. So half of pi over 2, that's going to be pi over 4. And then, so if we count by pi over, like if we look at just, fourths, so we're going to come back over, we're going to go, okay, that's 1 pi over 4. 2 pi over 4 is pi over 2. So let's go another one. It's going to be 3 pi over 4. Okay, 4 pi over 4 is just pi. Let's come down to the next 45 one, which is 225. So that's going to be 5 pi over 4. 6 pi over 4. I'm going to write it out here and simplify it. So 6 pi over 4. Those are both even. If you divide 6 by 2, you get 3. And you divide 4 by 2, you get 2. So that's 3 pi over 2. So that's one way to look at it, 3 pi over 2. And then you can also look at it like, well, that's 1 half, 2 halves, 3 halves, like that. And then we're back over here to 4 pi over 2, or 2 of those pi's. We got 1 pi, 2 pi's. So 360 degrees is 2 pi. And then, of course, in radians, 0 is still 0. Okay, so that's got the measurements, all the different ones for the fourths and the halves. Let's go to the 30s. Okay, so if I look at 30 degrees, I want to see, how many times does 30 go into 180? Well, it goes 6 times. So 30 degrees, 30 degrees is pi over 6. So since 30 degrees is 1/6, 30 degrees is 1/6 of 180, then 30 degrees is 1/6 of pi. So that is just pi over 6. Okay. 60 degrees, 60 goes into pi, or I'm sorry, 60 goes into 180 3 times. So 60 degrees is pi divided by 3. Okay, so let's look at that. Let me get rid of this down here. Okay, so 60 is pi over 3. And pause as often as you need to. So 60 is pi over 3. If we get over here to 120, 60 times 2 is 120. So that means that 2 of those, 2 times pi over 3, 2 pi over 3. Okay. And then 60 more would be down here. That would be our 3 pi over 3, which is just pi. Get down here to this next 60. So 180 plus 60 more would be our 240. So that gives us 4 of those. So that's 4 pi over 3. 60 more gets over here to 300. So that's 5 pi over 3. And then 6 pi over 3 gets us back up here to 2 pi. Okay, so now let's look at the pi over 6. So we've got pi over 6, 2 pi over 6 we already have. So if we're going by 30s, 30, 60, 90. So this is 1 pi over 6. 2 pi over 6 is the same as pi over 3. 3 pi over 6 is the same as pi over 2. 4 pi over 6 is the same as 2 pi over 3. Now, right there, that one's not filled in. That one's 5 pi over 6. Because it didn't line up with anything else. So that one's 5 pi over 6. Okay, we get down here to 6 pi over 6. Well, that's equal to pi. The next one, go up 30 from 180, and we get to 7 pi over 6. 7 pi over 6. Okay, then we get down here to the next 30, and it's 8 pi over 6. We get to this next one, it's 9 pi over 6. This one's 10 pi over 6. This one is 11 pi over 6. Looks like I missed a 35 in there. Maybe I erased it. Let's see. But so this one is 11 pi over 6. Okay, we missed a 315. So let's go back and see where I erased it. So we've got pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4. That would have been 7 pi over 4. So 7. I got the wrong thing there. Changed my pencil. Okay, there we go. 7 pi over 4. So you need to make sure you get all of that. Get all of those degrees and radians in there. So we got to make sure we have all that. So, and then I'm going to probably give you a clearer copy of this too. So you'll be able to see that. But let's also look up here. So, so we talked before about how this is the first quadrant. And in the first quadrant, X and Y are both positive. This is the second quadrant. And in the second quadrant, X is negative, Y is positive. In the third quadrant, they're both negative. And in the fourth quadrant, you've got X is positive. This is third quadrant. Fourth quadrant, you've got X is positive and Y is negative in the fourth quadrant. Okay. So that's all of your degree measures, radians, and now we're going to start looking at coordinates. Okay, so all of the trig functions are what help us with the coordinates for this. So I'm going to erase this, and we're going to go back. I think it was that last picture, or maybe it was the next picture. This one. Yeah. Okay. So I told you that sine is y and cosine is x. So if we look at 30 degrees, actually, maybe I had, let's see, did I bring that one up? I didn't. Dang it. Let me do some different pictures here, different photos. So this one, this one. Okay, that's the one I want. Okay, so you need to, if you didn't already, get this. If you didn't write this down as I was taking notes on it, make sure you take a screenshot of this, or pause it and take the notes and make it look exactly like this. This is what you're going to need to use to go by. Because what happens is, so like all of those angles, they're at 60 degrees. The sine or the y is going to be square root of 3/2. And it might be positive, it might be negative. And all of the x values are going to be 1/2 at all of the multiples of 60 degrees. And then all of the multiples of 30. Let's see. Well, I'm not really saying that right. Anyway, this is going to be our y. This is going to be our x. And then y and x. So cosine is y, x. I'm sorry, cosine is x, sine is y. I'm kind of getting ahead of myself and my brain's not working. But let's see how this works. Okay, so this is the first quadrant. If you can get the first quadrant, you're going to be good to go on all of it. So if you notice here, we said that the sine of 30 is 1/2, so the y value is 1/2. The cosine of 30 is square root of 3/2, so the x value is square root of 3/2. Okay, and then for 45, this is 45 degrees. Okay, and so if we're looking at that, square root of 2/2 is your cosine, and your sine is square root of 2/2. So that's your x and your y. Same thing. So, and then like we said before, x and y trade places, cosine and sine trade places up here at 60. So x or cosine is 1/2, and y or sine is square root of 3/2. So if you get this part filled in for that first quadrant, then that's going to help you for the rest of the way, all the way around the circle. So I'm going to go back and pull up the unit circle again, and we're going to fill in, I'm going to help you fill in those values. And I didn't bring it up for this one, so I have to bring it back up. Okay. So, okay. All right. So that's what we did so far. We got 30 degrees is that first line. And so then this part right here is looking for the x and the y. So the cosine of 30 degrees gives you your x, which I'm going to put these in black so they might show up a little bit better. And so that's going to be square root of 3/2. And then sine is giving you your y, so that's 1/2. And then cosine and sine are both square root of 2/2 for 45 degrees. So that gives you your x and your y. And then we just trade places with x and y up here at 60. So x is 1/2, y is square root of 3/2. So we're just going to worry about those for now. So, yeah, we'll come back to the 90, the 0, 90, 180, and 270. Okay, so now what I want you to look at is that this is 30 degrees. Well, this right here is also 30 degrees. So 150, from 150 to 180, that's a 30-degree angle. So these coordinates are going to look just like these, except for x is going to be negative, because I told you up here x is negative in that quadrant. So this is just going to be negative square root of 3 over 2. Still positive 1/2 since y is positive. Okay, then if we look at 45 over here, for 45, we've got square root of 2 over 2 for both x and y. Still going to be square root of 2 over 2 for both x and y over here, but since x is negative in the second quadrant, x is going to be negative square root of 2 over 2, and y is positive square root of 2 over 2. And then, so now we look at 60. Well, this 120, 60 degrees is called a reference angle. So the reference angle for 120 is 60. And so if you look up here, it's going to be the same x and y, but x is going to be negative. So over here, we've got negative 1/2 and positive square root of 3 over 2. So too sloppy. Okay, so moving on down. Move down here. And in the third quadrant, 210 minus 180, that's a 30-degree angle right there. So our reference angle is 30. That's our reference angle. So if our reference angle is 30, our x and y are going to be the same as 30. It might not be the same sign, but they're going to be the same values without the sign. So it's still going to be square root of 3 over 2 and 1/2. But if we notice down here, they're both negative. So those are both going to be negative. And then for 225, our reference angle is 45. So it's negative square root of 2 over 2, negative square root of 2 over 2. And then if I take 240, subtract 180, my reference angle is 60. So up here, 60 degrees, those are my x and y values, although in the third quadrant, they're going to be negative. So x is going to be negative 1/2, and y is going to be negative square root of 3 over 2. So you're just doing the same thing all the way around. You're not having to do it over and over and over again. Okay, so let's go into the fourth quadrant, same thing. So if we look at 330 in the third quadrant to get the reference angle, I go 360 minus 330. And that gives me that 30-degree angle. So I'm looking up here at 30 degrees. So, and I look, the x is positive, the y is negative. So, this, I get square root of 3 over 2 and 1/2, negative 1/2. And then here I get positive square root of 2 over 2 and negative square root of 2 over 2, because that reference angle is 45. The reference angle for 300 is 60. So I get positive 1/2 and negative square root of 3 over 2. Okay, now this is the unit circle. So that means that the length of this is 1. So from here to there is positive 1. So at 0, the x is 1. And y, it's on the x-axis. So everywhere on the y-axis, y is 0. If I go over here to 180, it's a distance of negative 1 from the origin and still 0 for y. So it's negative 1 and 0. Okay, if I go up to 90 or pi over 2, this is positive 1, up positive 1. So that y would be 1. And then it's on the y-axis, so your x value is 0, and that 0 could look nicer. Okay, so down here, straight down, that's still y on the y-axis, so x is still 0, and y now is going down 1, so it's -1. So what this tells us is that the cosine of 0 is 1, and the sine of 0 is 0. The cosine of 90 is 0, and the sine of 90 is 1. Because remember, cosine is the same as x, sine is the same as y. All right, so now, these little words right here, positive and negative. So this is asking us, in the first quadrant, which of the trig functions are positive and which are negative. So in the first quadrant, the sine, the cosine, and the tangent are all positive. All three are positive. Okay. Now, over here in the second quadrant, the only positive one is y. So the positive one is sine. Okay. The two negatives are cosine and tangent. And that's because tangent, tan theta equals sine theta over cosine theta. That's also related to slope. It's like change in y over change in x. You can kind of think about that. It's kind of maybe a thought for the future. Okay, now when you get down here in the third quadrant, which ones are positive, which ones are negative? Well, the negative ones, both the sine and the cosine are negative. So the negatives are sine and cosine. But now, since the tangent is the sine divided by the cosine, the tangent is positive down here. And then if we get over here to the fourth quadrant, we've got cosine is positive, and then the negatives are sine and tangent. Okay, there is an acronym to remember that. So the acronym is, in the first quadrant, they're all positive. In the second quadrant, only sine is positive. In the third quadrant, only tangent is positive. And in the fourth tangent or quadrant, only cosine is positive. And so there's a little, you know how you have, please excuse my dear Aunt Sally. The saying for this one is all students take calculus. Students prefer all students take cocaine. All students take crack. I don't know. Anyway, all students take calculus. They're all positive in the first quadrant, the sine only, tangent only, and cosine only. So ASTC, however you can remember that. That gets your unit circle all filled out, and I will make sure you have a copy of it to check to make sure that you got all of that right. Okay.